Hello and welcome back to my channel. In this video, I am sharing some of the most important 5 marks questions from the chapter Continuity and Differentiability. So most of these questions have appeared for the final exams in the previous question papers. So any one of these questions might come for your exam. So make sure you study all of these questions thoroughly, as one or two of these questions might appear in your final exams. Let's solve the questions one by one. Okay, first question. If y equals 3 into e raised to 2x plus 2 into e raised to 3x, prove that d square y by dx square minus 5 dy by dx plus 6y equal to 0. First we write the question. Y equals 3 into e raised to 2x plus 2 into e raised to 3x. Let's name this as equation number 1. Differentiate this equation with respect to x. Upon differentiation, we get dy by dx is equal to 3 into differentiate e raised to 2x. Differentiation of e raised to 2x is e raised to 2x into differentiation of 2x is 2 plus differentiation of 2 into e raised to 3x. 2 is a constant. Differentiation of e raised to 3x is e raised to 3x itself into differentiation of 3x is 3. Now next step, 3 into 2, 6. 6 into e raised to 2x plus 6 into e raised to 3x. This is the equation number 2. Now we'll differentiate again with respect to x. Upon differentiating this equation, we get d square y by dx square equal to differentiation of 6 into e raised to 2x. 6 is a constant. Differentiation of e raised to 2x is e raised to 2x into differentiation of 2x is 2 plus differentiation of 6 into e raised to 3x. 6 is a constant. Differentiation of e to the power of 3x is e raised to 3x itself. Differentiation of 3x is 3. Next step, we are multiplying this. 6 into 2, we get 12. 12 e raised to 2x plus 6 into 3 is 18. 18 e raised to 3x. Let us name this equation as equation number 3. Now we are substituting equation 1, 2 and 3 in this equation. That is d square y by dx square minus 5 dy by dx plus 6y equal to 0. What is d square y by dx square? It is 12 e raised to 2x plus 18 e raised to 3x minus 5 into what is dy by dx. dy by dx is equation number 2, that is 6 e raised to 2x plus 6 e raised to 3x plus next equation plus 6 into y. y is equation number 1, that is 3 into e raised to 2x plus 2 into e raised to 3x. Upon solving this, finally we get the answer as 0, hence proved. Next is, if y equals sine inverse of x, show that 1 minus x square d square y by dx square minus x dy by dx equal to 0. Let's write this equation. Y equals sine inverse of x. Differentiate this equation with respect to x. What we get is dy by dx is equal to differentiation of sine inverse of x is 1 by root of 1 minus x square. Now we'll bring this root of 1 minus x square to LHS. So we get root of 1 minus x square into dy by dx equal to 1. Now we have to differentiate this equation again with respect to x. Upon differentiation, we have two functions here, that is root of 1 minus x square and dy by dx. So we have to use the UV rule to differentiate this. What is UV rule? D by dx of UV is equal to u into v dash plus v into u dash. Upon applying this formula here, we get u, that is root of 1 minus x square into differentiation of dy by dx, that is d square y by dx square plus v into u dash. V is dy by dx into u dash, that is d by dx of root of 1 minus x square is d by dx of root x is 1 by 2 root x. Same thing we apply here, 1 by 2 root of 1 minus x square. Then again differentiation of 1 minus x square is, differentiation of 1 is 0 minus of differentiation of x square is 2x equal to 0. Now we'll multiply both LHS and RHS by root of 1 minus x square. Upon multiplying, we get root of 1 minus x square into root of 1 minus x square d square y by dx square plus dy by dx into root of 1 minus x square divided by 2 into root of 1 minus x square into minus 2x. This root of 1 minus x square and root of 1 minus x square will get cancelled. What remains is root of 1 minus x square into root of 1 minus x square is 1 minus x square d square y by dx square minus of, here 2 and 2 will get cancelled. So minus x remains into dy by dx is equal to 0. Hence proved. This is the answer. Now we'll go to the next question. If y equals 5 cos x minus 3 sin x, prove that d square y by dx square plus y equal to 0. We'll write the question here. Y equals 5 cos x minus 3 sin x. Let this equation be number 1. Differentiate this equation with respect to x. So dy by dx is equal to 5 is a constant. Differentiation of cos x is minus sin x minus 3 is a constant. So remains same into differentiation of sin x is cos x. Let us name this equation as number 2. Now again we are differentiating this equation with respect to x. That is d square y by dx square is equal to, differentiate this minus 5 sin x. It will become minus 5 cos x minus of 3 into differentiation of cos x is minus sin x. So we'll get minus 5 cos x plus 3 sin x. Name this as equation number 3. Substitute 1, 2 and 3 in this equation, that is d square y by dx square plus y equal to 0. What is d square y by dx square? It is minus 5 cos x plus 3 sin x plus what is y? 5 cos x minus 3 sin x. So upon cancelling we get 0 as the answer. This is the answer, hence proved. We'll go to the next question. If y equals cos inverse of x, find d square y by dx square in terms of y alone. We'll write the given question here. Y equals cos inverse of x. This can be written as cos y equals x, right? Now we are differentiating this function with respect to x. So differentiation of cos y is minus sin y into dy by dx. Differentiation of x is 1. Now we'll bring this minus sin y to RHS. So when we bring minus sin y to RHS, it will become dy by dx is equal to minus of 1 by sin y. 1 by sin x can be written as cosecant x. Same thing we are applying here. Dy by dx is equal to minus of cosecant y. Now we are differentiating this equation again with respect to x. So what we get is d square y by dx square is equal to, what is the differentiation of cosec x, cosecant y? It is d by dx of cosecant x is minus of cosecant x into cot x. So differentiation of cosecant y is this minus sign, I'll put it outside, and the differentiation is minus cosecant y into cot y. Since y term is here, we write dy by dx. Minus into minus is plus. So what remains is cosecant y into cot y into dy by dx. Dy by dx can be written as minus of cosecant y. Substitute dy by dx as minus of cosecant y. So cosecant y into minus of cosecant y, you will get minus of cosecant square y into cot y. This is the answer. We'll go to the next question. If y equals 3 cos log x plus 4 sin log x, show that x square y2 plus x y1 plus y equal to 0. Here y2 is nothing but d square y by dx square and y1 is nothing but dy by dx. So I am writing the question here. Differentiate this equation with respect to x. So what is dy by dx? 3 into differentiation of cos of log x is minus sin of log x. And again differentiation of log x is 1 by x plus 4 into differentiation of sin log x is cos log x, and again differentiation of log x is 1 by x. Dy by dx is equal to, x is common for both the terms, so we'll take it as common denominator, and minus of 3 sin log x plus 4 cos log x. Now we'll bring this x term to LHS. So x into dy by dx equal to minus 3 sin log x plus 4 cos log x. Now we'll differentiate this function with respect to x. We have two functions here, x and dy by dx. So we need to use this UV rule. So on applying this UV rule, we get u into dv by dx, that is x into d square y by dx square, plus v into du by dx. V is dy by dx and differentiation of x is 1, equal to minus 3, differentiation of sin log x is cos log x, again differentiation of log x is 1 by x, plus differentiation of 4 cos log x is 4 is a constant. Differentiation of cos log x is minus sin log x, and differentiation of log x is 1 by x. So x into d square y by dx square plus dy by dx equal to, x is common for both the terms, so x, I have taken it as a common denominator, minus 3 cos log x minus 4 sin log x. Now again we'll bring this x term to LHS. So we'll get x square into x square into d square y by dx square plus x into dy by dx equal to minus 3 cos log x minus 4 sin log x. Now x square into d square y by dx square plus x into dy by dx equal to, we can write this term given 3 log x plus 4 sin log x is equal to y. This is given in the question. So I'm replacing this whole thing by y, minus of y. Next step, I'll bring this minus y to LHS, so we'll get plus y. So x square into d square y by dx square can be written as y2, x square into y2 plus xy1 plus y equal to 0. Hence proved. We'll go to the next question. If y equals a into e raised to mx plus b into e raised to the power nx, show that d square y by dx square minus of m plus n dy by dx plus m and y equal to 0. So I am writing the question here, y equals a into e raised to mx plus b into e raised to nx. Now I'll differentiate this equation with respect to x. So dy by dx equal to, a is a constant, remains same, a into differentiation of e raised to mx is e raised to mx, and differentiation of mx is m, plus b into differentiation of e raised to nx is e raised to nx itself, and differentiation of nx is n. dy by dx is equal to a into m into e raised to mx plus b into n into e raised to nx. This is equation number 2. Now we'll differentiate this equation again with respect to x. What we get is differentiation of dy by dx is d square y by dx square equal to differentiation of this a into m into e raised to mx is a into m into, both are constant, e raised to mx. Differentiation of e raised to mx is e raised to mx into differentiation of mx is m, plus b into n into e raised to, differentiation of e raised to nx is e raised to nx, and differentiation of nx is n. So we'll get a into m is m square e raised to mx plus b into n is n square e raised to nx. Now we'll substitute 1, 2 and 3 in d square y by dx square minus m plus n dy by dx plus m and y equal to 0. Upon substituting, we'll get, what is d square y by dx square? Equation number 3, a into m square into e raised to mx plus b into n square into e raised to nx minus m plus n into, substitute dy by dx, that is equation number 2, a into m into e raised to mx plus b into n into e raised to nx plus m into n into, substitute y, that is a into e raised to mx plus b into e raised to nx equal to 0. Upon solving this, we'll get the answer as 0. Next question is, if y equals 500 into e to the power of 7x plus 600 into e to the power of minus 7x show that d square y by dx square equal to 49y. Let's write the question here. Y equal to 500 e raised to 7x plus 600 e raised to minus 7x. Let us put this as equation number 1. Now we'll differentiate this function with respect to x. So dy by dx equal to differentiation of 500 into e raised to 7x is 500 into differentiation of e raised to 7x is e raised to 7x itself into differentiation of 7x is 7 plus 600. It's a constant, so it will remain the same, into e raised to minus 7x. Differentiation of e raised to minus 7x is e raised to minus 7x into differentiation of minus 7x is minus 7. Dy by dx equal to, this 7 is common in both the terms, so we can take that outside. Remaining is 500 into e raised to 7x minus, this minus I have put it here, 600 into e raised to minus 7x. Let us put this equation as number 2. Now differentiate this function again with respect to x. So we'll get d square y by dx square is equal to 7 into differentiation of 500 into e raised to 7x is 500 into differentiation of e raised to 7x is e raised to 7x itself into differentiation of 7x is 7 minus 600 into differentiation of e raised to minus 7x is e raised to minus 7x itself, and differentiation of minus 7x is minus of 7. Next we'll take 7 is common in both the terms, so we'll take this 7 outside. So 7 into 7, 500 into e raised to 7x plus 600 into e raised to minus 7x. So d square y by dx square is equal to 7 into 7 is 49, and we know that y equals 500 into e raised to 7x plus 600 into e raised to minus 7x. This is given in the question. So we are replacing this by y. So d square y by dx square equal to 49y. Hence proved. Next question is, if e to the power of y into x plus 1 equal to 1, show that d square y by dx square equal to dy by dx the whole square. So the question is, e to the power of y into x plus 1 equal to 1. We'll differentiate this function with respect to x. Now we can see that there are two functions here, e to the power of y and x plus 1. To differentiate this, we need to use the uv formula, that is d by dx of uv equal to u into dv by dx plus v into du by dx. On applying this uv rule, we get u into dv by dx. U is e to the power of y, e to the power of y into dv by dx, that is differentiation of x plus 1, that is 1 plus 0, plus v into du by dx. What is v? V is x plus 1. X plus 1 into du by dx, that is d by dx of e to the power of y. So differentiation of e to the power of y is e to the power of y into dy by dx, which is equal to d by dx of 1 is 0. We can write this as e to the power of y plus x plus 1 into e raised to power y dy by dx equal to 0. Now I'll take this e to the power of y to RHS. So we'll get x plus 1 into e to the power of y dy by dx is equal to minus of e to the power of y. This e to the power of y and this e to the power of y will get cancelled. What remains is x plus 1 into dy by dx is equal to minus 1. Or you can write dy by dx is equal to, I'll take this term to RHS, that is minus of 1 by x plus 1. Now again I'll differentiate this equation with respect to x. So this function is of the form u by v. So we need to apply the quotient rule to differentiate this function. So what is quotient rule? D by dx of u by v equal to u dash into v minus v dash into u divided by v square. So Upon differentiating, we get d square y by dx square equal to, I'll take this minus sign out, into u dash into v. What is u dash? Differentiation of 1, that is 0, into v. V is x plus 1 minus v dash into u. What is v dash? Differentiation of x plus 1, that is 1 plus 0, into u, that is 1, divided by v square, that is x plus 1 whole square. So this is 0. 0 minus 1 into 1 is 1, divided by x plus 1 whole square. We can write it as d square y by dx square equal to 1 by x plus 1 the whole square. Now in the question we have, prove that d square y by dx square equal to dy by dx the whole square. So we'll take the RHS now. What is dy by dx? Dy by dx is minus of 1 by x plus 1. Substitute dy by dx here. That is minus of 1 by x plus 1 into minus of 1 by x plus 1 equal to, minus into minus will become plus, that is 1 by x plus 1 the whole square, which is nothing but the LHS. So d square y by dx square equal to dy by dx the whole square. This is the answer. If y equals tan inverse of x whole square, show that x square plus 1 whole square y2 plus 2x into x square plus 1 y1 equal to 2. First, let's write what is given. Y equals tan inverse of x whole square. Now you have y1 and y2 here. What is y1? Y1 is nothing but dy by dx, and your y2 is nothing but d square y by dx square. Now we'll differentiate the given function with respect to x. So we get dy by dx is equal to differentiation of tan inverse of x whole square. First step is 2 into tan inverse of x, and then differentiate tan inverse of x. What is the differentiation of tan inverse of x? It is 1 by 1 plus x square. We know that tan inverse of x is equal to, derivative of tan inverse of x is nothing but 1 plus x square. Now we'll take this 1 plus x square to LHS. So we get 1 plus x square into dy by dx equal to 2 into tan inverse of x. Now we'll differentiate this function again. So in LHS we have two functions, 1 plus x square and dy by dx. So we need to apply the UV rule. Consider this function as u and this function as v. We'll apply the UV rule here to differentiate this function. What is UV rule? D by dx of u into v equals u into dv by dx plus v into du by dx. We'll apply this formula here. What we get is u is 1 plus x square into dv by dx, that is differentiation of dy by dx. We get d square y by dx square plus v into du by dx. What is v? dy by dx into u, differentiation of 1 plus x square. Differentiation of 1 is 0. Differentiation of x square is 2x equal to 2 into differentiation of tan inverse x is 1 by 1 plus x square. Now again we'll take this term to LHS. So we get 1 plus x square into 1 plus x square is 1 plus x square whole square d square y by dx square plus 2x into, this term will go here, so 1 plus x square into dy by dx equal to 2. We know that dy by dx is y1 and d square y by dx square is y2. So we can write this as x square plus 1 whole square y2 plus 2x into 1 plus x square into y1 equal to 2. Hence proved.